Hello, I'm Dr. Rick Whitman. This is Module 6 of your Science 100 class, Perspectives in Natural Science at Southern New Hampshire University. Today I'm going to do three things with you. They are how to succeed in Module 6, in other words, an introduction, how journal articles work in science literature, I'll show you an example, and then some information about PowerPoint. This is necessary for your Module 8 requirement, which is good because you'll have a little less to do this week and next week than you have had in previous weeks. Now, as you begin Module 6, you'll see that there are really only two requirements for turn-ins this time: a short answer with a rubric, by the way, and a quiz, standard quiz, 20 points. First element here continues this curiosity that we've had and been exploring. This one is why ask why, the nature of scientific inquiry. And that is, we're exploring the reasons that humans pursue scientific inquiry. Why do we ask questions? What makes a good answer? What happens when we get that first answer? Is there a second or a third or a fourth? And in fact, that's how this works. There's a web page that goes with this you'll find interesting. And it gets into, I'll enlarge this, why we ask why. And it gives you a library article to check out. And then it goes into a longer discussion here. As you read, think about a time in your life when you really wondered about something related to the natural sciences and asked why. When you were young, you probably asked why about everything, as well as the time you found yourself skeptical of reports of scientific discovery or headline. Good for you. It's how we want to be. And next, we're going to get into how to shape questions, or how we ask questions so that they build on previous work, or that we make the most of our chance to ask a question. So there's 20 big questions that have happened in science. You'll enjoy this one. It's a hoot. And then following on that, there's 10 questions that people lined up to ask Stephen Hawking a while ago. Unfortunately, he's just passed away, but this guy wrote everything from the leading scientific papers of our age, as well as popular books for the general public called Brief History of Time. In fact, there's more than one version of that. And he also wrote children's books. Not bad for a guy in a wheelchair that couldn't speak. He also managed to make some appearances on Big Bang and on Star Trek. So what you want to do when you're done with this is recognize how scientific developments inform scientific questions. How do we build from what we know to what we want to know, and keep going. After that, you're going to have a short answer requirement: why ask why. Now, here's the trick, and here's where I really want you to focus. You will score better because you will have a more complete answer if you answer in at least 3 paragraphs each one of these. You want to cut and paste these into your as a lead into your separate paragraphs? Do that if it helps you think through. Here's the trap. Comment on what you think. That doesn't mean you say I, me, or myself. And in fact, if you do, you're thinking more like you were still in grade school. In college work and in academic work, we don't write in the personal pronouns. I, me, myself really does not belong. Here's why. Your paper has your name, or should every time. If your paper has your name, if you keep saying I or me in your paper, it reads as if you have no confidence in what you're saying, you don't know what you're talking about, or you don't have a clue how to go about it. Either way, it convinces many readers, especially college instructors, that you are not ready for prime time. So, write your paper if you want. Start by writing I or me, but go back and correct it and edit it and rewrite it so that you're not saying I or me. You could say Stephen Hawking and others ask why in order to do the following. You also want to limit your use of the words I've told you about: be, am, is, are, was, were, being, and been. Commas have a place, semicolons have a place, periods have a place. This is a possessive, apostrophe yes. Questions end with question marks. Some of you don't know this or haven't used them. So your second question would answer, your second answer would answer, how has Hawking's research contributed? So you need to go back and look at what he's done and how it's impacted the larger field of science in general. And then the third question is the real tough one here. When you consider the work of natural scientists in general, not just Hawking but others, how do you think developments in scientific thinking end up influencing how science study is carried out? Provide an example. You're going to need some of this for Project 3, which is Module 8. That's the tough one for this semester. It's worth 120 points or 12% of a grade. Scoring well on that will help you keep your B or your A, or may cause you to fall a grade, so you want to pay attention to that. And then there's this rubric, which I've showed you before, which shows you how you're going to be graded. If you think I'd give you a grade for anything, you're telling me you're not ready for college work. I grade, and all your other instructors grade on your performance against a standard. Not a lot of subjectivity here. Let's continue. We're going to get into what drives scientific exploration. Why do we think what we think? And then you're going to look at this guy, Kirk Johnson, who's been on PBS, by the way. He's a rock star geologist, pun intended here. I hate these ads that come up. And what you want to do is to learn a little bit more about this guy. He is as big as Neil deGrasse Tyson is and is going to be. And this guy is still fairly young, so he's going to be around for quite some time. Cool stuff. Lastly, you're going to look at Ebola vaccine and why that's a real hot topic right now. Ebola is one of the world's worst diseases. It is very pathogenic. In other words, it attacks people, and when it does, it's quite virulent. Your chances of surviving are not great if you're not treated. And it is endemic, or appears often in Central Africa. The real problem that plagues transportation planners, for example, is if someone were to get on an airplane in Central Africa and fly to Paris or Brussels or Paris, I said Paris, or London, for example, it's about a 5-hour flight. If they were not sick when they got on the plane, they could be almost dying by the time they get off. They will have contaminated most of the people on the plane, who in turn go down the terminal, get on an airplane, fly to New York, another 5-hour flight, and by the time they get off, you can see where this could produce a chain reaction of very serious death in a hurry. Now, following this, you have your last quiz, your only quiz this week, another 20-pointer. You're allowed to take it twice. These are not easy, so if you don't do well on the first try, go back and look at it a second time. You'll be glad you did. And now onto some other material. You heard me say that I was covering 3 things this week. You've already seen me cover the intro to Module 6. I'm going to talk to you about a journal article, what a science journal article is, and give you an example of one. Then I'm going to talk to you a little bit more about PowerPoint, because it's crucial for your Module 8 and you have time to get ready for it. Now, I wanted to show you what a real scientific journal looks like. I pulled this one up at random. This is from a malaria journal, which I follow occasionally. It's from 2011. It's the volume number and the page number that this started on. This has multiple authors. So if it were only 2, if it was 1, it would say Gething, PW. If it was Gething and Patil, it would say Gething and Patil. And if this was in APA format, those names often would appear in parentheses with a comma, and then the date of the publication, which is 2011. In this case, because there's all these authors, 1, 2, 3, 4, 5, 6, 7, 8, it would say Gething et al., period, which means everyone. The way these journals work is, and I'll show you, they usually start with what's called an abstract. Now the abstract typically is a summary of what the article is about, and nearly always it includes a little bit about the background, a tiny snapshot of the methods, and a little bit about the conclusions. This one is a little different in that it's so complex. It's actually brought out in each of the major areas why they did what they did, how they did the malaria testing that they did, the results they achieved, and the conclusions, what all this research meant. I'm going to show you some pieces of this because I think you'll find it fascinating. Now, to begin with, they start with why are we doing this, as I mentioned. And this is part of what's called a Malaria Atlas project, and they're actually researching a type of malaria called Plasmodium falciparum. Plasmodium, capital P, is the genus of the the bacteria that causes malaria. Actually, it's a protozoan, and this is the species. So the genus is always a capital P, and the species is falciparum. This is one of the 4 types of malaria, and it's considered one of the hardest ones to control. Now, usually in an academic article, they'll nominate one of the contributing authors as the corresponding author. In other words, if you have questions about it, whose name would you put in? I also noticed this is something I'd not ever seen before. This contributed equally, so they're not. Oftentimes, the name that appears first gets the lion's share of the credit, but in reality, 1, 2, 3, 4. These 4 did the lion's share of work, and these others commented. I want to show you something very important about these. After the background, they're from England, so it gives an address where the principal authors are. Then they get into the background, how they generated a global map of where this is endemic, the endemicity rate, current rate at which it's spread. And here they look at all of the particulars, and this is called a figure, and it shows you how they conducted their study. And let me go further. This is beyond certainly a 100 level science, but really good scientists will produce figures or maps or charts to summarize what their data shows, because when you're testing thousands and thousands of people in multiple countries, it sometimes works better to map your details. So this goes on for several pages. I'm going to page down here the other way, and here they were giving their results, and they even show their error rate is pretty small, which is kind of interesting. And then they get into where it's the worst, and this is all mostly around the equator, as you can tell. We don't get in our area of the woods. And here's some tables that summarize where the risks are and where they're progressing. And again, this is now the countries that were involved, which is kind of interesting. National level comparisons. And then I go a little further. And then they go into discussion of what this means. So they're talking about the risk. Now, malaria actually affects more people across the world than any other disease, so this really is important. And here they're explaining where they have differences in the results. Why did they get it? Do they have a reason for it? And then they release their material. They also have additional information available online, and I like this part here. They have to also state who gave them funding. This project is funded by Biomedical Resources grant from this trust group, this would be in England, and Global Health Program in Oxford Tropical Network and elsewhere. these people are really, they have to tell who they are, where they're from, what their contributions were. For example, here's details of the different authors. All this, and all authors contributed to refining experiments in the final version of this manuscript. The authors declare that they have no competing interests. Unlike the tobacco project that most of you did a few weeks ago, where the tobacco companies were actually paying scientists to produce questionable data, these guys are required to, the journals require them now to decide whether or not they are involved elsewhere. And what you don't know, the difference between this time, it was received in early November and published close to the end of December, and the reason it was is because it was actually put out to at least 2 what's called blind reviewers, people that are smart about this particular disease, this falciparum version of Plasmodium, but who were not involved in the project. And so what they were able to do is to get it verified that this really does look good and the numbers really do reflect, the math holds up for what they're saying. This is an example of really good research where the people have to lay it out on the table. How did they do what they did? Do they have any competing interests? Who contributed what? And in the scientific community, if you lie in a journal, you die. You won't get published again, and you're going to be ignored after this. Now, and finally, I wanted to mention a little bit about PowerPoint. I'll show in the announcement that publishes this YouTube a link to a generic starter set on how you produce PowerPoint. But what I'm showing here on this page is an example of a PowerPoint. Now, if I want to really jazz this up, I would have a figure, perhaps something over here that would relate to what I'm saying. What you want to do when you're doing your PowerPoint, frankly, is over the next week, think about it and notice that when I make presentations to you here, you don't see word after word after word on the PowerPoint slides. I tell you very simply what we're doing. PowerPoint is usually used for briefings, which means no one's reading to you. It's self-explanatory. So if somebody were to read this, if you didn't have sound on your system, you would know that these are the things that I covered this time. Module 6, sample of journal article and some information about PowerPoint. That's all I have for now. You'll see a separate video on PowerPoint soon.